Welcome to Section 3, Lesson 3. In the previous lesson, we mastered two-step linear equations using the reverse PIMDAS rule to apply inverse operations in the correct order. Today, we extend the workflow one more step to handle equations where the variable x appears on both sides of the equals sign. The extension is a single preliminary step. Gather all the variable terms onto one side and all the constant terms onto the other side, then run the standard two-step procedure on the resulting one-sided equation. The gather step is straightforward once you understand the principle, and after this lesson the same workflow handles every standard linear equation you will encounter in the rest of the course, on standardized tests, and in introductory science and engineering work. First idea on the board. A both sides linear equation has the form ax plus b equals cx plus d, where the variable x appears on both the left and the right of the equals sign. The structure is still linear, meaning x appears only to the first power, no roots, no x in denominators. The both sides feature is the only structural change from the previous two lessons, and it requires only a single new step in the solving procedure, rather than a whole new toolkit. Second idea, the new step is the gather step. Use the balance principle to move all the variable terms onto one side of the equation and all the constant terms onto the other side. Concretely, you subtract the smaller variable term from both sides to eliminate it from one side, and you add or subtract any constant from both sides to push it to the other side. After the gather step, the equation has the form one combined variable term equals one combined constant term, which is the one-step or two-step form we already know how to solve. Third idea, there is a small craft choice in the gather step that minimizes the work. Gather the variable terms to whichever side has the larger coefficient, so the resulting coefficient is positive and you avoid working with negative coefficients. 5x minus 3 equals 2x plus 9, for example, has a 5x term on the left and a 2x term on the right. Subtracting 2x from both sides leaves 3x on the left and 0x on the right, with a positive 3x coefficient. Subtracting 5x from both sides instead would leave negative 3x on the right, which works mathematically but introduces an extra negative sign step at the end. Always choose the gather direction that produces a positive coefficient when you have a free choice. A both sides linear equation has the form x plus b equals cx plus d, with the variable x appearing on both the left and the right of the equal sign. The structure is still linear because x appears only to the first power. The both sides feature is the only structural change from previous lessons, and it requires just one preliminary gather step before the standard two-step procedure takes over. Here is the gather step. Use the balance principle to subtract the smaller variable term from both sides of the equation, eliminating that variable from one side and combining it with the other variable term on the other side. After the subtraction, the equation has the variable on one side only, and the gather step is complete. Constants can be moved similarly using addition or subtraction. Step 1 in the workflow. Inspect the two variable terms and decide which side to gather to. Choose the side with the larger coefficient, so the resulting combined coefficient is positive. In the equation 5x minus 3 equals 2x plus 9, the larger coefficient is 5 on the left, so we gather to the left by subtracting 2x from both sides. Step 2. Subtract 2x from both sides. The left side becomes 5x minus 3 minus 2x, which combines to 3x minus 3. The right side becomes 2x plus 9 minus 2x, which simplifies to 9 because the 2x terms cancel. The equation has been reduced to 3x minus 3 equals 9, which is the standard two-step form from Lesson 2. Step 3. Apply the two-step procedure from Lesson 2. Reverse PIMDAS says undo the addition or subtraction first, then undo the multiplication or division. Add 3 to both sides to get 3x equals 12. Then divide both sides by 3 to get x equals 4. Verify by substitution 5 times 4 minus 3 equals 17 on the left, and 2 times 4 plus 9 equals 17 on the right. Both sides equal 17, so x equals 4 is the solution. Here is the first worked example. Solve the linear equation 5x minus 3 equals 2x plus 9. The variable appears on both sides with coefficients 5 and 2, and there are constants minus 3 and plus 9 on the two sides. The workflow is gather first, then two-step inverse procedure. Step 1. Choose the gather direction. The left side has the larger variable coefficient at 5, so gather to the left by subtracting the smaller term 2x from both sides. This will leave a positive coefficient on the left and 0 variable on the right. Step 2. Subtract 2x from both sides. The left side becomes 5x minus 3 minus 2x, which combines to 3x minus 3. The right side becomes 2x plus 9 minus 2x, which simplifies to 9 because the 2x terms cancel. The equation is now 3x minus 3 equals 9, the standard two-step form. Step 3. Apply the reverse PMDS two-step procedure. Add 3 to both sides to undo the subtraction. The left side becomes 3x minus 3 plus 3, which simplifies to 3x. The right side becomes 9 plus 3, which equals 12. The equation is now 3x equals 12, the one-step form. Step 4. Divide both sides by 3 to undo the multiplication. The left side becomes 3x divided by 3, which simplifies to x. The right side becomes 12 divided by 3, which equals 4. The solution is x equals 4. Verify 5 times 4 minus 3 equals 17, and 2 times 4 plus 9 equals 17. Both sides equal 17, so the solution is verified. So the solution is x equals 4. The big lesson from this example is the gather step layered on top of the two-step procedure from lesson 2. Gather to the side with the larger coefficient to keep the resulting coefficient positive, then apply reverse PEMDAS to solve the one-sided equation that remains. 3 steps total: gather, undo addition or subtraction, undo multiplication or division. The verification step uses the evaluation skill from section 2 and catches any arithmetic slip in the solving steps. Practice the gather step on a few dozen problems, and the workflow becomes a fast, reliable reflex within a week. Here is the second worked example. Solve the linear equation 4 times the quantity x minus 2 equals 2x plus 6. The variable appears on both sides, but the left side has parentheses that need to be distributed before the gather step can run. The workflow is therefore distribute first, then gather, then two-step inverse procedure. 3 layers of work, all on top of the section 2 distribution skill we built earlier in the course. Step 1. Distribute the 4 across the parentheses on the left side. 4 times the quantity x minus 2 becomes 4x minus 8. The equation is now 4x minus 8 equals 2x plus 6, with parentheses gone and the variable still on both sides as expected. Step 2. Choose the gather direction. The left side has the larger variable coefficient at 4, so gather to the left by subtracting the smaller term 2x from both sides. Step 3. Subtract 2x from both sides. The left side becomes 4x minus 8 minus 2x, which combines to 2x minus 8. The right side becomes 2x plus 6 minus 2x, which simplifies to 6. The equation is now 2x minus 8 equals 6, the standard two-step form. Step 4. Apply reverse PEMDAS. Add 8 to both sides to undo the subtraction, giving 2x equals 14. Then divide both sides by 2 to undo the multiplication, giving x equals 7. Verify 4 times the quantity 7 minus 2 equals 4 times 5 equals 20. 2 times 7 plus 6 equals 14 plus 6 equals 20. Both sides equal 20, so the solution is verified. So the solution is x equals 7. The big lesson from this example is the layered workflow: distribute to remove parentheses, gather variable terms onto one side, then apply the two-step inverse procedure. Each layer uses a skill from a previous lesson, and stacking them in the right order is the entire game in solving harder linear equations. Distribution from section 2. the gather step from this lesson, and the two-step inverse from yesterday all come together to solve any standard textbook linear equation in 3 to 5 steps. Today's pattern handles the vast majority of linear equations in the rest of the course and is the foundation for the harder solving techniques in later sections. 3 mistakes that catch every algebra student during their first weeks of both sides equation work. Each one is fixable with a small explicit habit applied on every solve. First mistake, choosing the wrong direction for the gather step and ending up with a negative coefficient. A student sees 5x on the left and 2x on the right and subtracts 5x from both sides instead of subtracting 2x, leaving the equation with negative 3x on the right and an extra negative sign divide step at the end. The work is mathematically correct but unnecessarily long. The fix is to always inspect the two coefficients before gathering and choose the side with the larger coefficient, so the resulting coefficient is positive and the rest of the work runs cleanly. Second mistake, dropping a sign or losing track of a variable term during the gather subtraction. A student writes 5x minus 3 minus 2x and combines incorrectly to get 7x minus 3 instead of 3x minus 3, adding the variable coefficients instead of subtracting. The arithmetic mistake is cheap, but its propagation through the rest of the solve produces a wrong final answer. The fix is to write the gather step explicitly with the subtraction shown vertically below the original equation, so the arithmetic on each variable term is visually obvious. Third mistake, skipping the distribute step when parentheses are present and trying to gather variable terms with the parentheses still in place. A student sees 4 times the quantity x minus 2 equals 2x plus 6 and tries to subtract 2x from both sides immediately, but the 4x is hidden inside the parentheses and the gather step does not reach it. The fix is to scan the equation for parentheses before any gather step and distribute every parenthesized chunk first. Only then is the equation in the standard both sides form ready for gathering. Both sides linear equations appear constantly in real-world balance and equilibrium problems across science, engineering, and economics. Anywhere two competing quantities must be equal at the answer, a both sides equation is the modeling tool of choice. 4 broad sectors below. In physics, free body diagrams produce equations of the form sum of forces on one side equals sum of forces on the other side, with the unknown often appearing in both summations. The both side solving procedure isolates the unknown force or acceleration with the same gather, then two-step workflow we covered today. Every introductory physics class is filled with both sides equations that beg for the technique you learned in this lesson, and getting the technique solid now pays off across the entire physics sequence. In economics, market equilibrium is defined as the price at which the supply quantity equals the demand quantity. The supply function and the demand function are both expressions in price, and solving for the clearing price is a both sides equation in the price variable. Microeconomic problem sets across every undergraduate economics curriculum rely on exactly this kind of solving, and the algebra is precisely the workflow we covered today. In business break-even analysis, the total cost function on the left equals the total revenue function on the right at the break-even unit count. Both functions involve the unit count variable, often with a fixed cost on one side and a per-unit margin on the other. Solving for the break-even unit count is a both sides equation, and small business owners do this calculation regularly to decide whether a new product line is worth pursuing. In engineering tolerance and load analysis, the structural stress tolerance of a material on one side equals the applied stress on the other side at the maximum acceptable load. Both expressions involve the load variable, and solving for the maximum load is a both sides equation that engineers compute on every design review. The skills you are building this week are the everyday currency of mechanical, civil, and electrical engineering. Three things to take with you from this lesson today. Both sides linear equations are the most common form of linear equations seen in equilibrium and balance problems across science, engineering, and economics. And the layered workflow you have built today scales directly into the harder multi-step solving you will see in many later lessons later this term. First, the both sides structural form is ax plus b equals cx plus d, with the variable appearing on both the left and right sides of the equal sign. Recognizing the both sides form on any equation tells you the procedure gather first, then two-step. The structure is still linear, so all the section 3 solving techniques apply with just the one extra preliminary step. Second, the gather step uses the balance principle to subtract the smaller coefficient variable term from both sides, eliminating it from one side and combining it with the other variable term on the other side. Always inspect the two coefficients before gathering and choose the side with the larger coefficient, so the resulting combined coefficient is positive. Choosing the wrong gather direction is mathematically correct but introduces an extra negative sign step at the end of the solve, wasting time. Third, after the gather step, the equation is in the standard two-step form from lesson 2, and the reverse PIMDS procedure takes over to isolate the variable. When parentheses are present in the original equation, distribute them first before any gather step. Gathering through unsimplified parentheses is the most common subtle error in both sides equation work. Coming up next, the lesson called literal equations, where instead of solving for a numerical value of the variable, we solve for one variable in terms of other variables, a key skill that turns formulas into reusable tools across physics, finance, engineering, and applied math. Literal equation solving uses exactly the same inverse operation procedure you have built across these last 3 lessons, just with letters instead of numbers as the constants on the right side after the variable is isolated.